Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. For your information, this is the last lecture for topic 9, differentiation. Lecture 5 of 5 is related to subtopic 9.5, parametric differentiation. The objective for this lecture is to use parametric differentiation to find the first and second derivative. Let's get started. First derivative of parametric differentiation, dy over dx. Suppose x and y are both function of the same independent variable t, then the equation x equals to ft and y equals to gt are called parametric equation, and t is called the parameter. By using the chain rule, we can differentiate parametric equation dy over dx equals to dy over dt multiply dt over dx, or dy over dt divided by dx over dt. Let's look at for example 1. Find dy over dx in terms of the parameter t if x equals to 3 over t, y equals to sed 1 plus t squared. This is the first equation. The second equation is find dy dx in terms of the parameter t if x equals to negative cos 3t and y equals to 2 sine square 3t. For question A, we have x equals to 3 over t and y equals to sed 1 plus t squared. To find dy dx in terms of the parameter t, we need to find dx over dt and dy over dt. So first we need to differentiate x equals to 3 over t, which is x equals to 3t power negative 1. And this is suppose we can apply rule of differentiation x power n, and we get n x power n minus 1. So then dx over dt is equal to negative 3 over t squared. Then after that, we find dy dt. Since y equals to sed 1 plus t squared, so this one we can apply a power rule. So to apply power rule, we change y equals to 1 plus t squared power 1 over 2. So first you need to bring the power bring in front. So then we get dy over dt equals to 1 over 2, 1 plus t squared, and then power suppose minus 1 multiply by differentiate 1 plus t squared. It's become 2t. So then we get dy dt equals to 1 over 2 multiply 1 plus t squared power negative 1 over 2. This is suppose 1 over 2 minus 1 multiply differentiate in the bracket, we get 2t. So then, by using the chain rule, dy dx equals to dy dt multiply dt dx. So we substitute into this chain rule. So dy dt is dy dt is 1 over 2, 1 plus t squared, power negative 1 over 2 multiplied by 2t, multiply dt over dx. Since dx over dt is negative 3 over t square, so dt dx we can kita boleh terbalikkan dia lah. So dia akan jadi t square over negative 3. So then after that we can simplify dy dx. So for this case kita boleh cancel. We can cancel 2 and we get finally we simplify, we get negative t cubed over 3 sed 1 plus t squared. This is the answer in the simplest form for dy over dx. For question B, we have x equals to negative cos 3t and y equals to 2 sine squared 3t. So first we need to find dx over dt and dy over dt. So we differentiate x equals to negative cos 3t, we get dx over dt equals to negative Then we differentiate cos 3t, we get negative sine 3t. And then we need to differentiate angle 3t, and we get 3. And finally, we get dx dt equals to 3 sine 3t. And then we differentiate y equals to 2 sine square 3t. So for this case, you need to apply a power rule. So bring power to the front. So then it's become 2 times 2 sine 3t. And then we differentiate sine, we get cos 3t. And then we differentiate 3t, we get 3. So finally, you get 12 sine 3t cos 3t. And then, using the chain rule, dy over dx equals to dy over dt multiply dt over dx, we substitute into this chain rule. So we get 12 sine 3t cos 3t multiply 1 over 3 sine 3t. And then we can cancel out sine 3t and we can cancel out 3. So finally we get 4 cos 3t. So this is dy over dx in the simpler form for parametric differentiation for question B. Let's continue with example 2. If x equals to t over 1 plus t and y equals to t square over 1 plus t, and for t and t does not equal to negative 1, show that dy dx equals to t multiplied t plus 2. Okay, for this question, we are going to show dy dx, and the information here is x in terms of t and y in terms of t. So we can apply parametric differentiation since dy dx equals to dy over dt multiplied dt over dx. So first we need to find dx over dt. To get dx over dt, we need to apply x in terms of t. Since x equals to t over 1 plus t, so then we need to apply quotient rule. So for this quotient rule, let u equals to t and v equals to 1 plus t. So u prime equals to 1, v prime equals to 1. So then we apply quotient rule. Suppose it start with v. So then dy over, dx over dt is equal to 1 plus t. Suppose start with v, 1 plus t multiplied by 1 minus t multiplied by 1, since the formula is vu prime minus uv prime over v square. So over 1 plus t square. So then we simplify, we get 1 over 1 plus t square. So this is dx over dt. So then, okay, for dy dt, we can find by differentiate y equals to t square over 1 plus t. So then, since y is in the form u over v, we can apply quotient rule. So let u equals to t square and v equals to 1 plus t. So then u prime is equal to 2t, v prime equals to 1. We differentiate 1, it becomes 0, t becomes 1. Then dy over dt, we apply quotient rule formula, which is vu prime 1 plus t multiplied by 2t minus uv prime t square multiplied by 1 over 1 plus t square. So then we simplify, we get 2t plus 2t square minus t square over 1 plus t square. So then we get 2t plus t square over 1 plus t square. So then we can factor t, we get 2 plus t over 1 plus t square. Now we get dx dt equals to 1 over 1 plus t square and dy dt equals to t multiplied to plus t over 1 plus t square. So by using chain rule, we can find dy dx equals to dy over dt multiplied dt over dx. So then dy dt is t multiplied 2 plus t over 1 plus t square multiply 1 plus t square. So dt over dx is 1 plus t square over 1 lah. Suppose kita terbalikkan dia daripada dx dt. Then after that we can cancel out 1 plus t square. Finally we get t multiplied 2t plus t. So this is, kita dapat show lah, is shown. Now let's continue with example 3. Find the value of dy dx if x equals to t minus 1 over t and y equals to 2t plus 4 over t when t equals to 2. So this is similar from previous example. So first, but this one we want to find the value of dy dx. So first we need to find dx dt and dy dx. So x is equals to t minus t power negative 1. So then we differentiate, we get 1 minus then t power negative 1 we can differentiate, it's become negative t power negative 2. So then it is become t plus t power negative 2, which is 1 plus 1 over t square. Then we simplify, we get t square plus 1 over t square. For this case, we equate denominator. Then after that, we are going to find dy dt. So since y equals to 2t plus 4 over t, so then 4 over t is become 4t power negative 1. So then we differentiate to t, we get 2 plus, suppose is minus 4t power negative 2. So then we get 2 minus 4 over t square. So then we equate denominator, we get 2t square minus 4 over t square. Now we have dx dt and dy dt. To get dy dx, we use formula, you use chain rule, dy over dt multiply dt over dx. So we substitute 2t square minus 4 over t square. So this is dy over dt multiply dt over dx. You suppose kena switch. So then multiply t square over t square plus 1. Alright, so we can cancel out t square. So we get 2t square minus 4 over t square plus 1. So then to find the value of dy dx when t equals to 2, so we substitute. So we get dy dx equals to 2 multiply 2 square minus 4 over 2 square plus 1. So finally we get 4 over 5. So the value of dy dx is 4 over 5 when t equals to 2. Second derivative of parametric equation. Second derivative of y with respect to x. The answer for dy dx are usually in terms of parameter t. So in order to find the second derivative, we will apply the chain rule again. If x equals to ft and y equals to gt, thus second derivative of y with respect to x equal, we differentiate with respect to x, we differentiate dy dx with respect to x, equals to differentiate dy dx with respect to t multiply dt over dx. So therefore, differentiate of y with respect to x is equal to differentiate with respect to t dy dx multiply dt dx. Let's look at for example 4. The terms of parameter t is given by x equals to 2 over 1 minus t square and y equals to t over 1 minus t. Show that dy dx equals to 1 over 4 multiply 1 minus t. And b, find second derivative of y with respect to x. For x equals to 2 multiply 1 minus t power negative 2. So for this case, we can apply power rule. So to find the x dt, we apply power rule. So we bring negative 2 to the front. So then it's become dx dt equals to 2. 2 kat depan tu salin. We copy 2. Then we bring power negative 2. And then 1 minus t power should be minus 1. It's become negative 3. And then we differentiate in the bracket 1 minus t. We get negative 1. So then we simplify. We get 4 over 1 minus t cube. And then for y equals to t over 1 minus t, we apply quotient rule. We get dy dt equals to 1 minus t multiplied by 1 minus t multiplied by negative 1 over 1 minus t square. This is quotient rule. So then we simplify. We get 1 minus t plus t over 1 minus t square. Then we get 1 over 1 minus t square. And then to get dy dx, so we apply chain rule. Dy dt multiply dt dx. Dy dt is 1 over 1 minus t square multiply dt dx. Suppose we switch, we get 1 minus t cube over 4. So then finally 1 minus t square we can cancel out. So finally we get 1 minus t over 4 or 1 over 4 multiply 1 minus t. So jadi kita dapat shun. For question B, we are going to find second derivative of y with respect to x. So then we apply, we differentiate dy dx with respect to t multiply dt dx. This is general for second derivative of y with respect to x. So first, we need to differentiate with respect to t. Differentiate 1 over 4 multiply 1 minus t multiply dt over dx is 1 minus t cube over 4. So to differentiate 1 over 4 minus 1 over 4t, we get 1 over negative 1 over 4 multiply dt over dx, which is 1 minus t cube over 4. So finally we get negative 1 over 16 multiply 1 minus t cube. Let's see example 5. If x equals to t e power 2t and y equals to e power 2t, find dy dx, second derivative of y with respect to x at 0.01. So for this case, we want to find the value of dy dx and second derivative of y with respect to x at 0.01. So x equals to 0, y equals to 1. So since to find dy dx, we use parametric differentiation, which is dy over dt multiply dt over dx. So then you will get dy dx is in term of t. So since the equation given is at point is in term xy, so then you need to find value t. To get t, you substitute x equals to 0, y equals to 1 into whether x equals to t e to t or y equals to e power 2t. So then first you need to find dx dt. since x equals to t multiply e power to t, this is product rule. So let u equals to t and u prime is equal to 1. V equals to e to t, so then v prime equals to 2e to t. So then dx dt equals to t multiply 2e to t plus e to t multiplied by 1. So then we factor e to t, it's become 2t plus 1 multiply e to t. So this is dx dt. So for y equals to e power to t, so dy dt equals to 2e to t. Now we want to find dy dx, which is dy over dt multiplied dt over dx. So we substitute into dy dt is 2e to t multiply dt over dx, we switch. So we get 1 over 2t plus 1 multiply e to t. So then we can cancel out. So we get answer, we get dy dx in the simplified form, which is 2 over 2t plus 1. So then dy dx equals to 2 over 2t plus 1. So jadi kita perlukan nilai t to get the value of dy dx. So jadi yang dia bagi dekat soalan is value x equals to 0 and y equals to 1. So then awak boleh pilih lah whether awak nak cari nilai t tu untuk boleh pilih sama ada awak ganti dekat x ataupun dekat y. Dia akan dapat jawapan yang sama lah. So let's say when x equals to 0, kita gantikan. So then we get t equals to 0. So then dy dx equals to 2 over 2 multiplied by 0 plus 1. So finally we get 2 over 1 which is equals to 2. So dy dx yang kita dapat ni adalah bernilai 2. So then for question B, we want to find second derivative of y, the value of second derivative of y at 0.01. So then we need to differentiate dy dx with respect to t multiply dt over dx. So kita kena differentiate dy over dx with respect to t, which is differentiate 2 over 2t plus 1 in term of t multiply dt dx, suppose 1 over 2t plus 1 multiply e power to t. So jadi kita differentiate lagi sekali 2 over 2t tambah 1 tu, we can apply power rule, which is 2 multiply 2t plus 1 power negative 1. So then it's become negative 2, 2t plus 1 power negative 2 multiply by 2. So then you get negative 2, 2t plus 1 power negative 2 multiply by 2 multiply 1 over 2t plus 1 multiply e power 2t. Then you can simplify. You can by apply rule of indices. So 2t plus 1 power negative 2 minus 1. So then you get negative 4 over 2t plus 1 cube multiply e power 2t. So this is second derivative of y with respect to x. So now we substitute the value t, which is t equals to 0, into negative 4 over 2t plus 1 cube multiply e power 2t. So then negative 4 over 2 multiplied by 0 plus 1 cube e power 0. So finally we calculate and we get negative 4.